नमस्कार दोस्तों, welcome back to VNP networking tutorials. In today's lab, we will learn how to configure iBGP, that is internal BGP, using Loopback IP address in GNS3. By the end of this video, you will understand why Loopback interfaces are preferred in BGP and how to configure them step by step. So let's start. So I will take here 3 routers. The router series is Cisco 2691. So I will be taking R1, R2 and R3 routers. So let's connect the physical interfaces of these routers with each other. From R1 fast Ethernet 0/0 to R2 fast Ethernet 0/0. From R1 fast Ethernet 0/1 to R3 fast Ethernet 0/0 and fast Ethernet 0/1 to fast Ethernet 0/1 on the R3. So this is our topology. Let me just align this fast Ethernet interfaces. Now the network which we are using between R1 and R2 is 10.12.12.0/30. The IP address on fast Ethernet 0/0 on R1 will be .1 and on fast Ethernet 0/0 of R2 router will be .2. The network segment between R1 and R3 will 10.13.13.0/30. The IP address on fast Ethernet 0/1 for router R1 will be .1 and the IP address on fast Ethernet 0/0 of R3 will be .2. The network segment between R2 and R3 will be 10.23.23.0/30. The IP at R2 site will be .1 and the IP on the R3 side will be .2. Now the BGP we are using is iBGP, hence the AS number will be same. So for here I am using the AS number 65,000. We are using the iBGP, so the 65,000 AS will be the common for all 3 routers. Let me also define the loopback IP on R1, R2 and R3. For R1, the loopback IP will be loopback IP 1 will be 1.1.1.1/32. The loopback IP on R2 will be 2.2.2.2/32 and the loopback on R3 will be 3.3.3.3/32. So let's power on all the routers and start with the configuration part. You can click this green icon to start all the routers. Okay, and you need to take the console access of each router. So click R1 and you can see the console option. Okay, we have R1 console access. Click R2. Get the console access and right click R3 and get the console access. So we have console access for all 3 routers. Now we will start with configuration of all the routers. I have already predefined the configuration for the interfaces and the OSPF and the BGP on a notepad to make the things faster. So here you can see that the configuration for R1 router. For R1 we will have the host name as R1. The loopback interface 1 will have the IP of 1.1.1.1/32. On R1, the fast Ethernet 0/0, which is connecting to R2, will have the IP of 10.12.12.1/30, and the interface will be no shut to make it enable. On fast Ethernet 0/1, which is connecting to R3 router, the IP address is 10.13.13.1/30. Make the interface no shut. Also, I will be using the OSPF as an internal routing protocol, because if we do not use any routing protocol, whether you use OSPF, EIGRP or RIP routing protocol, internal routing protocol is very much required here, because without internal routing protocol, R1 will not be able to reach the loopback of R2 or R3. R2 router will not be able to reach the loopback of R1 or R2, and same for R3. R3 will not be able to reach the loopback of R1 and R2. So unless and until we run the OSPF routing protocol and we advertise the directly connected network, for example, on router R1, you can see that the network 1.1.1.1 is advertised in area 0, and the two directly connected networks 10.12.12.0 and 10.13.13.0, which are directly connected for R1. We are advertising all these three network in the OSPF so that other routers R2 and R3 will come to know how to reach this network. And especially we want to reach the loopback IP. We want to reach this loopback 1.1.1 from R2 and R3 so that they can form the BGP peer formation or BGP neighborship accordingly. So I will paste this configuration on the R1 router. I hope you got the clear understanding of the configuration. I will just copy it and paste it on the R1 router. Config T and paste the configuration. Okay. So let me first save the configuration using the write command. Let's see the interface IP status. Show IP interface brief. Okay, so I can see that on R1 we are having the loopback IP configured as expected, along with the IP address on to physical interface. The interface is up and the protocol is also up. Let's check the routing table. Show IP route. As of now, I can see only the directly connected routes because there is no OSPF neighborship formed. Let's check the OSPF neighborship. Okay, we don't have any OSPF neighborship. Show IP protocols to verify we are having any routing protocol or not. Yes, we are running the OSPF routing protocol, and the router ID for the OSPF is 1.1.1.1, and the three networks which we are advertising in the OSPF is 1.1.1.1, which is the loopback of R1, 10.12.12.0 and 10.13.13.0. But since we have configured only the R1 router, so we don't have any OSPF neighborship. Let's configure the outer router now. Similarly, I also have the configuration for R2 router already created on the notepad. So let's go through the configuration. For R2, the hostname will be R2. The loopback IP is 2.2.2.2/32 as per our topology. The fast Ethernet 0/0 on R2, which is connecting to R1 router. You can see this R2 fast Ethernet 0/0 connecting to R1 router. It is having the IP 10.12.12.2 and mask is /30. You can see here on the topology diagram. Fast Ethernet 0/1, which is connecting to R3, is having the IP 10.23.23.1 and the mask is /32. Sorry, /30. We are also configuring the OSPF router on R2, and we are advertising the directly connected networks 10.12.12.0, 23.23.0, and we are also advertising the loopback IP because we want this loopback IP to be learned by R1 and R3 routers so that they can reach while forming the BGP neighborship. So I will copy all this information, all this configuration, and paste it on the R2 router. Config T. Let me paste the configuration. Hand command. Let me check the interface IP and status. So I can see all three interfaces are having the IPs as expected. The interface is up, the protocol is up. Okay. Let me see if any OSPF neighbor is formed because I can see that one log message for the OSPF. So I believe that one OSPF neighbor should be formed with the R1 router. Yes, I can see one OSPF neighbor is formed with the neighbor ID 1.1.1.1, and this is the remote address with which we are forming the OSPF neighborship, and the local interface is fast Ethernet 0/0. Okay, let me check if I am getting any OSPF routes or not. Show IP route OSPF. Okay, I can see that R2 is now learning the loopback IP of the R1. Okay, and we are also learning the network 10.13.13.0, which is the network between R1 and R3. Okay, so at least we are now getting the network learned from the OSPF. So let me save the configuration and show IP protocol to confirm that OSPF is running, and we are advertising the required network. So you can see that OSPF is running and the router ID is 2.2.2.2, and these are the three networks which we are advertising. Okay, now let me go to the configuration of R3 routers. The hostname will be R3. The loopback IP is 3.3.3.3/32. And the fast Ethernet 0/0, which is connecting to R1, is having the IP 10.13.13.2/30. Fast Ethernet of R3, fast Ethernet 0/1 is connecting to R2 router. Okay, and you can see the IP 10.23.23.2/30. And this is our OSPF configuration, which I will configure on the R3 so that it will advertise the loopback IP 3.3.3.3 and the two directly connected networks. So let's configure this on R3. Config T. Let me paste the configuration. Okay, let me save the configuration. Let me check the interface status. So I can see that all three interfaces are having the IPs as configured. The status is up, the protocol is up. I can see some OSPF logs which shows that R3 is now having the neighborship form with R1 and R2 router. Let's verify that with the command show IP OSPF neighbor. Okay, I can see that we have two neighbor for R3. One neighbor is with R1, another OSPF neighbor is with R2 router. Okay, let me check the OSPF routes learned through this. Okay, now you can see that R1 knows how to reach the loopback of R1, how to reach the loopback of R2, and how to reach the network, physical network between R1 and R2. Now you can see that we have two different paths available. Okay, from R3 you can reach this network via two paths. Okay, R3 you have two paths. One is through the R1, another one is the R2 path to reach the 10.12.12.0/30 network. Okay, so let me verify the connectivity from R1 to the loopback of R2 and R3. I will ping 2.2.2.2 with the source of 1.1.1.1. Yes, I am able to reach the loopback. Let me ping R3's loopback. Yes, I am able to ping. So R1 is able to reach the loopback of R2 and R3 without any issue. Okay, let me try from R2. I will try to ping the loopback of R1 using the source interface 2.2.2. Yes, I am able to ping. How about the R3? Okay, R3 loopback is also reachable. Let me check from R3. I will try to ping the loopback of R1 first. Okay, it's reachable. Let me try to ping from R2. R2's loopback. Okay, it's also reachable. So one thing is clear that we have complete network reachability between the loopback of R1, R2 and R3. Now the stage is set to configure the BGP. Okay, so I have also pulled out the configuration for the BGP in the notepad. First we will try to understand the configuration, then I will go ahead with the configuration on the routers. Okay, first thing is on R1, this is the BGP configuration. We are using the AS number 65,000. This is the BGP router ID 1.1.1.1. Now we are forming the neighborship with R2, but you observe that neighbor command 2.2.2.2. 2.2.2 is not a physical interface IP. Okay, this IP belongs to the loopback. Now from R1, we are trying to form the BGP neighborship with R2, but not the physical IP, because you can see physical IP is in the range of 10.12. Okay, but here I am mentioning that I want to form the neighbor with the loopback IP. Okay, with the remote AS number 65,000, which means that it will be iBGP. My local AS is 65,000, remote AS is 65,000, so that will be iBGP. And neighbor 2.2.2, but the update source, see my update source is loopback 1. I am not using my physical interface on R1 to form the BGP neighborship. I am using the loopback interface on the R1. Same cases with the R3 neighbor. I am forming the neighborship with R3 3.3.3.3, which is the loopback IP of R3, and remote AS is 65,000. And the loopback update source is, you can see the update source, loopback 1. Okay, so I'm not using any physical interface to form the BGP neighborship. Okay, so I will go ahead and put this configuration on the R1 router. Okay, config T. Let me paste the configuration and right. Let me check the BGP summary. You can see that the BGP is never formed. You see here never, and the state is active. Active means bad. The BGP is not formed. And these are two of our neighbors, 2.2.2.2 and 3.3.3.3. Because BGP is not configured on R2 and R3. So I will quickly go on R2 and configure the BGP configuration. You can see here the BGP configuration. Local AS is 65,000. BGP router ID is 2.2.2.2. I am forming BGP neighborship with R1. You see the loopback IP of R1. And remote AS is also same, 65,000, which means it is a iBGP. Very important command, update source is loopback 1. I am not using any physical interface. Okay, so on R2 I will put this configuration. So it will form BGP neighborship with R1 and R3. Okay, I will put the config command, then I will paste the configuration. Okay, let me save it. And you can see one log message popped up, which shows that the BGP is up with the R1 router, because R1 is having the BGP configuration, but not the R3. Let's see, show IP BGP summary. Show IP BGP summary. Okay, you can see this. R2 is having a BGP neighborship with R1, which is having the loopback 1.1.1.1 and remote AS is 65,000, and you can see here up and down. Since 28 seconds the BGP is up. If I just put up arrow enter, it will increase. Since last 48 seconds the BGP is up. Okay. Now I will proceed with the BGP configuration on the R3 router. Same steps we are following. We are using the loopback IP to form the BGP neighborship. So here we will form the BGP neighborship with R1 and R2 router. This is for R3. This configuration is for R3. So let's go and paste the configuration. Let me write it. And let's see if we see any BGP log message popping up to show the status. Okay, perfect. You can see that on R3 we see two neighborship forming, right? So let's confirm show IP BGP summary. Okay, you can see here that R3 is now having a BGP pair with R1 and R2. Okay, both are up since 13 seconds. Let me put up arrow and enter. The time will increase. Okay, so we have now stable BGP pair formed between R1, R2 and R3. Now let's check the failover scenario. Okay, let's check the failover scenario. How we can check that? I will shut down the interface between R1 and R2. Okay, I will shut down the interface between R1 and R2 means let's see, I will shut down this interface fast Ethernet 0/01 R1 and see if the BGP goes down or not. Okay, you see that BGP is shut down. Sorry, the interface is shut down. Physical interface is shut down. Okay, let's see the status now. What happens? Let me check the BGP summary. Okay, I can still see the BGP is up and stable. See, the BGP is stable even though that interface is shut down. Show IP interface brief. Okay, you see this fast Ethernet 0/0, which is connecting between R1 and R2 is shut down. But still the BGP with R2 is up and stable. Why is it so? Because still I can reach to 2.2.2 from source interface 1.1.1 without any issue. Okay, we have not formed BGP over physical interface. Okay, we have not formed BGP over the physical interface. We are using the loopback update. Also, the peer IP is loopback. Okay, so we are not forming the BGP over the physical interface. We are using the loopback interface. Hence, even with the physical interface shut down, we have BGP stability. We don't see any BGP flap. Still the BGP is up and stable. You see this. This is because we have alternate path. This is because R1 loopback can still be reached via R3. Okay, we have shut down the interface on R1 fast Ethernet 0/0, but still the remote IP, peer IP is reachable via the alternate path via R3. Okay, there is no flap on the BGP. Okay, I will again make the interface up. And you will see that there is no flap. The interface is up now. Okay, and there is no flap in the BGP. You can see that the OSPF neighborship is again established, but the BGP is stable. There is no flap in the BGP. So this is the benefit of using the BGP neighbor or configuring the BGP neighbor with the loopback IP. We should never use physical interface IP, but we should use the loopback IP when we have the redundant network. So even if the one link goes down, you will have the BGP redundancy. There will not be any BGP flap. I hope this video was informative and thank you for your time.